Cool. Am I recording? Yes. Cool. Hello, CSCI 221 students. I hope you guys had such a good time yesterday inside of our first in-person programming lab. I know I had a really nice time, and I got to look at most of your programming assignments and they look really good so far. I'm gonna try to get your My Story assignment, the first lab assignments, graded this afternoon and tomorrow morning. So hopefully they're all in this afternoon, but be on the lookout for those. And then the grade for the ones from yesterday or I'll go ahead and put those in soon as well. Alrighty. Without further ado, let's go ahead and get into our lecture for today. So we are in chapter 4, decision making. And I already posted the reading for that online. So let's just get into it. Um, 17th of February 2026. Love to see it. So let's just start off with a little welcome. Welcome to, maybe we'll do a haunted house kind of thing. Yeah, that sounds cool. Welcome to the CSCI haunted house. I wish I could think of something like creative computer science themed like haunted house. Like all I can think of is like bite back. I feel like I always put bite in it. I gotta think of something else. Oh, how about something like gigas and ghouls or something like that. Okay? Haha. Welcome gigabytes and okay, anyway. Let's get into it. So we just made a little print statement, nothing new there. But what we're going to get into today is decision making. And so I'm going to show you guys if else statements. And so I think a lot of you would have learned about if else statements, or I think in other terms you'll learn like a if then kind of thing in your English classes. And this isn't that far from it, right? If something happens, then we want something else to happen, right? We want to make a decision based on prior events. That's all our if else statements are doing, right? So this is how we do it in Python. Maybe we want to ask a question. Let's do entrance, and we'll do, will you enter the haunted house through the front door or the back door? Or maybe we'll give them or the side door. Why not? Will you enter the haunted house through the front door or the side door, right? And I like to do here, actually, I made that kind of long. So let's do this. Let's print our prompt and then entrance equals input, and then allow them to do, just kind of give them more information. Front, back. I could even say enter front or back, just to be really clear, right? So I haven't done anything crazy yet. Type a little, run a little. Welcome to CSCI Haunted House, Gigas and Ghouls. Will you enter the haunted house through the front door or the side door? Front. Oh, here we go. Let's give them the option side. Anyway, through the front door or the side door. Maybe this time I want to enter side, right? And so we know that the variable entrance is going to save the value of whatever they put in here, right? So now we're going to get into our if-else statements because we want to do something different if they enter the side door or if they enter the front door, right? So if entrance equals side, right? So this is saying if they've input side, they want to go into the side door, then I want to do this. And let's print you entered through the side door and got eaten by a zombie. Print. Let's do something like the end. Right? Else, meaning that you entered something else. Or let's do even elif. Elif entrance equals front, then print. Maybe we'll let them survive if they entered through the front door, right? So maybe if they entered through the front door, we'll say congrats, or we'll say you met, or you found a genie in a bottle. You found a genie in a bottle. You at the front door. You can make 3 wishes. Cool? So if entrance is side, else if entrance is front, else the entrance is they put something else that we didn't give them an option to, right? So we told them to enter through the front or the side. If they say window, then they have an invalid response. Then they have the invalid response because we didn't say that that was an option, right? Save. Let's run that thing. Welcome to the CSCI Haunted House Gigas and Ghouls. Will you enter the haunted house through the front door or the side? Let's enter through the side. You entered through the side door and got eaten by a zombie. The end. Aw. Let's try it again. Will you enter the haunted house through the front door or the side? This time, let's go in the front. And you found a genie in a bottle at the front door. You can make 3 wishes. And just to prove my point, if I said we entered through the window, even though the program didn't give us that option, it'll say invalid response, right? So that is our if-else statements. Those are our if-else statements. Just like a quick overhead. I'm just trying to get you guys to see the concept, the structure of it, right? If, elif, else. Okay. Now, going into the meat and potatoes a little bit more, this entrance equals side, right? So notice that, and this is a quiz question. This is a really good quiz question that I will always ask, or not quizzes, exam questions, since this is the accelerated hybrid. 1 equal sign is for assignment, right? So the variable entrance is getting assigned the value of whatever the user is putting in, right? Here, the double equal signs is not for assignment, it is for comparison. We are comparing the value of trance, right? The value of entrance to side. So we're comparing this to this to see if they are the same. Okay? 1 equal sign is for assignment. 2 equal signs are for comparison. Okay? Alrighty. So if entrance equals slide, do the following thing. So the other thing that I want to point out about this is that, right, this is going to be called the value in here is going to be called a Boolean right? Our if-else statements deal with Boolean data types. So what does that mean? What's inside of your if-else statement in between these parentheses? It needs to evaluate to something that is either true or false, right? It needs to evaluate to something that is either true or false. So maybe Booleans are either true or false. False. What is it? No, I did spell that right. Okay. So Booleans are either they entered side or they did not. Either they entered front or they did not. Either they entered something completely different or they did not. Okay? Your else statement doesn't have the parentheses. It's not taking in a Boolean because your else statement is literally handling all other cases that are not already being handled inside of the if else. Cool. Alrighty. Now we weren't letting them go in through the window, but how about we give them the chance to go in the window. And this is how we could add that. You entered through the window and are covered in broken glass. Print the glass stabbed you. The end. Okay? So this is also a conceptual thing, right? So even though I added this other option, I didn't put it inside of my prompt on line 9. So now, let's just go ahead and update our prompt so that the user knows that they have another option, right? Save, run that thing. So now if I do window, you entered through the window and are covered in broken glass. The glass stabbed you. The end. Okay? So what I wanted to really note is that you can make as many of these if-else as you want when you're checking something, right? But you only get that one else at the end, right? Because that one else is covering everything else. If you wanted, we could do all kinds of different entrances to the haunted house, right? Side, front, window. You could go through the chimney. You could go through the attic. You could go through I don't know. We can make all kinds of entrances, and that's what I'm trying to get at with adding additionally the window, is that we can continuously add to this as much as we want. Okay? Cool. So the other thing, what else did I want to look at with you guys in this video? Oh, okay. So that's if else statements. And I'll say with strings. So let's look at if else statements with numbers. There we go. So maybe we'll do something like you are on a diet and you want to, I don't know, maybe we'll call this like the calorie counter. Actually, let's do that. Welcome to the calorie counter. Print. We let you know what you are eating, or something like that. I don't know. Anyway, let's see. Let's do item calories is equal to input. So yeah, let's take some input from our user. Why not? How many? I don't know about y'all. I hate calorie counting. I actually. Anyway, I don't know why that was the first thing that came to mind. Like, because I don't do it. But anyway, how many? How many calories? Why did I do a capital C? Calories are in your item. Bam, bam. So also just a note for making clean, understandable code for your user. You see how I do those double dots? That's really letting your user know that it's their turn to type something in. And I saw a couple of you guys haven't been doing that, and it's not that I'm never going to take points off for that, but it is a good design because it makes it so much easier to run your programs when I know where I need to type, right? And so that's ideal for your users. I don't take points for that, but I could almost take design points for that just because. And well, anyway, so I hope you guys were sitting here thinking, oh, I created this variable called item calories and how many and then I asked how many calories are in your item, which means that the calories, right, they're gonna be a number. When they enter their calories, that's a number. So immediately, I hope that you said, oh, the data type of item calories is currently a string, right? So we're going to want to make sure that we turn that into a, can you have half a calorie? I mean, you could, but I feel like the calories, at least when they put it on the packaging, I feel like they normally give you a integer calories. So it'd be like 500 calories or 200 calories or whatever else, right? So I'm going to turn it into an integer data type. And we know what an integer data type is, right? Our integer data type is for, right, whole numbers, our counting numbers, right? Just a reminder that when you want to do math with numbers later, you have to convert it. You have to convert it and let the computer know that you entered numbers. Cool. I saw that coming up a little bit when we were in our lab, so I just want to really hammer that idea in. So let's see. So our idea is if something's I don't know what's considered a high calorie meal. I think over like 400. I think under 400 is a low calorie meal, right? So let's do over like 1,000 is a high calorie meal or something like that. I don't know. So if the calories that they entered is greater than is greater than 1,000, then we want to print, dang, you eat a lot. No, I'm just kidding. We want to print high calorie, high calorie, high calorie meal. Yeah. Elif, Elif item calories. Let's say if it's less than, I don't know, what did we say, 400? I think we just said that 400 was a print. That's a low calorie meal, right? Or is it might be 3 something. I don't know. I'm not a nutritionist. We're just going for an example. Anyway, so then otherwise, if it's something else, then say I don't know, mid calorie. I don't know, mid calorie meal. Mid calorie meal. Maybe we'll give them like a nice job for the low calorie, right? Nice job. Cool. So save and run that thing. If I didn't make any mistakes. window. You went through the window, you're covered in glass. All right, so welcome to our, oh, I'm sorry. Let me put some white space in there so that you guys, we remember the \n is our new line escape character. Cool. There we go. So welcome to the calorie counter. We let you know what you are eating, how many calories are in your meal. Let's do 100. Low calorie meal, nice. Let's do, let's try 2,000 calories. High calorie meal, oh no. And let's do, let's do 550. Mid calorie meal. Cool, 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 cool. So that's how you can use if else statements with numbers using their, and these greater than, less than statements should be pretty familiar. I don't know when we learned that in school, but nothing new, just a little bit of a different structure with by putting it inside of the if else statements. Okay, sorry, I'm just looking at what else I wanted to show you guys today. All right, let's do some the or, the and the not. Or and not logic. Logic. Cool. Okie dokie. What I want to do, let's do A equals 100, B equals 300, and C equals 100, right? So, oh, you know something? I'm sorry. I feel like maybe I should have been zoomed in a little bit. Maybe like to there. I hope, don't be upset with me that if the text was coming up real small, my bad, guys. Back to what I was doing. So we could do something like comparison equals A greater than B or A greater than C, right? Print out the comparison. So, and I know like this, it seems weird, but the or and not logic will actually come in handy in like the weirdest ways. But anyway, so I created these three variables. A is 100, B is 300, and C is 100, right? Then I created this variable called comparison, which is going to hold a Boolean value, right? So and what does that mean again? Booleans are going to evaluate to true or false. So the first one we did here is A greater than B. Is 100 greater than 300? No. So that's going to be false. Or, so even I would almost put like, just for your notes, maybe do like a false there, false. Or is A greater than C? Also false. So this is going to evaluate to false. Run that thing. See, false. Sorry, I keep not putting in our, where do I want to put that? Let me just put that one here because I don't want it to look messy for our notes. There we go. And again, you guys here, I'll even put, \n is our new line character escape character is anyway, gives us a new line. Cool. Alrighty. So that's going to evaluate to false and false, and that gave us false here, right? Because it's saying if this is true or this is true, then comparison will be true. So let's do comparison 2, and we'll do is B greater or less than, I'm sorry, is B less than A, there we go, or A greater than C, right? So we know now, can I get over there and give you guys some notes, that B is 300 and 300 is greater than 100. So we know that this one should be true, but just like in the previous statement, A is not greater than C, right? 100 is not greater than 100. So this should be false. But since we're using OR logic, only one or the other needs to be true. So that should evaluate to true. So let's do comparison 1 in here. Maybe I'll put a 1 just for formatting's sake, and then print comparison 2. Comparison 2, which should evaluate to true, right? Because only one of them has to be true in order for this statement to be true. So let's run that thing if I didn't make any mistakes. There we go. False and then true. So that's our OR logic right there. OR logic. Cool. And then similarly, our AND logic might be comparison 3 equals. So for AND to work out, both statements need to be true, right? Both statements need to be true. So I could say something like B is greater than A, and let's do something like, let me make it just very simple. Let's do D is like 200, sure, okay? So that then we could do D greater than C, right? So then we have, and let's keep that true and true, so that this one should evaluate to true. Bam, bam, 3. Cool, so that's our AND logic. And then while I'm on this, I'll go ahead and make one that's false, right? So we'll do A greater than B and D greater than C, right? So in this instance, we know that the first one is false. We know that A is not greater than B, but we know that the second one is true. So we know that D is in fact greater than C, true. But it had to be both of them being true. So then comparison 4 should evaluate to false. 4. Beep. And I'll even separate these out. So let me put, because this is for the OR logic, and that is for the AND logic. Bam. Save that thing. Run that thing. Window. Cool. Right. So I should have put spaces again. Hold on. Let's just do it. Let's just do it. That way it's nice and clean to look at, and I'll even put some labels in there. And logic, and let's print OR logic. Here we go. Oops, no, I put it in. That's fine. Anyway, so just like we said, both of these are true, and so comparison 3 is true, but the first one is false, so comparison 4 is false. So that's for our and. And then the last one that I want to show you is the not logic. So sorry, I don't know why I just had a little brain. Anyway, let's do 5. It's equal to is, let's do, if they're equal, a, what is it? It's up. That might be in the wrong order. We're gonna test it. But anyway, this is saying not equal. So A does not equal B. So we would expect this to be false. And then comparison 6. If I put the thing on the right side, because what it is, I can't remember if it's like this or like this. It makes sense because not equal. It would make sense for it to be like that. Anyway. I'm probably right, but that's the beautiful thing about CS. You know in a matter of seconds once you run that thing. Anyway, so A is, oh, I'm sorry, this should be true. This should be true, right? Because A is not equal to B because A is 100 and B is 300. But this one should be false because A and C both equal 100, and so they do equal each other. It's not equals. If I feel like I said that weird. Okay, so listen. A and B are not equal to each other. The not equals, the not logic is checking. It's basically like the negative. It's checking like, hey, these two aren't the same. That's true. Okay? Run that thing. Run that thing. It's so, the logic is like funny to talk about, but let's run that thing. Oh, it wouldn't show up, right, if I didn't print it. That's a example of a logic error and not a syntax error, right? Because you're not going to see anything if I don't tell it to print to the screen, right? Right. Oh, I'm going over a little bit. Oh, we're almost there. Side, 200 calories. There we go. And then not. So, right, this evaluates to true because A does not equal B. And this evaluates to false because A sure does equal C. Okay. And let me put some new lines in there. Bam. Alrighty. We got through everything I wanted to get through. Fantastic. So as always, feel free to email me with your questions, thoughts, concerns. I hope you guys enjoyed this lecture, and I'm really looking forward to our lab on Monday. That is going to be so much fun. Once you learn decision making, programming starts going crazy, okay? And then once we get to looping, you're able to make so many cool applications. It's really mind-blowing. And we're even going to get to graphical user interfaces. And then I think that's really fun. I did a Tamagotchi lab for the graphical user interfaces last semester. So if anybody has ideas about what they want to do for the graphical user interface, I'm open because I think the Tamagotchi lab ended up being very cool. If not, we'll just do that one. Or if you guys are really excited about that one, then I'll keep that too. All right. Have a wonderful afternoon. And I can't wait to grade your wonderful, awesome, creative lab assignments. Bye, guys.